Hello guys, welcome back to my YouTube channel again. Today we are going to discuss about one of the most major topics ever, that is the Mangalyaan. As you know, before the introduction, I will introduce myself. My name is Sumay Despat, currently a 11th grader in Karnataka. I'm more passionate about space, science and everything. In this video, I will just try to explain the Mangalyaan mission in my own words. So I don't know about that much technicalities. Just I will inform you what about I know and the research I made. Like not like that much research. It's like seeing Google and analyzing the data. So first, before sorry for the sound there. Before discussing the main PPT which I have made, I will just show you the brochure. That means what ISRO has given the PDF for us. I hope you understood. So this is the brochure. I will just put the brochure link in the description there. Before this, I made a video on Chandrayaan 2 also, and even the space policy also. Please watch those videos. I think we pop up here or at the end of the video. That is the I button. Okay, this is just the introduction. This is the chairman ISRO. That time, Radhakrishnan sir was the ISRO's chairman. This is the clean room. Clean room is basically the room where the satellites are made, and they have to maintain some certain temperatures. Like when we visited, when I got a good chance to visit the ISRO center, they just not like 2014, 1 or 2 years back, they just showed a clean room. I think the Cartosat 3 was in building there. Means it has not launched it. It has to go to test and everything. They just showed and through the not they didn't take us inside the clean room. There is a view room there. Like a glass separates us and that room. The glass was itself so much cold. Can understand what temperature they have to maintain, and even one single component also may cost crores there. So you have to maintain that much dignity, that much cleanliness while you're building a satellite, because a dust particle may cause so much what you say disturbance in the spacecraft. And this is the Mars orbiter mission spacecraft getting into large space simulation chamber for testing. Before you have to send the satellite for the space, not even ISRO, every space agency does this. Like they create a simulation, like a space, like a simulation in Earth itself, like a zero gravity and the temperatures and the pressure, everything. Not pressure. Don't want to talk. The temperature and gravity, zero gravity, somewhat zero gravity, not like that. So this is the space simulation center available there. It is going for testing now. They are given the water planet Mars. Like this is a famous quote of Carl Sagan, sir. In more than one respect, the exploring of solar system and homestanding other worlds constitutes the beginning much more than the end of history. I hope you understood what Carl Sagan had said. I think you have heard about Carl Sagan, especially when he quoted about the photo of Earth from the Voyager spacecraft from Saturn itself, that blue dot. I hope you have heard about it. This is like they have given about the Martian planet. Like the atmosphere consists. Yeah, in this column they have given. I mean here they are given the what you say between comparison between Mars and Earth. Like in Mars, you have carbon dioxide itself. It constitutes 95.32% of the atmosphere. Like just compare with the Earth, it's just 0.038%. It's more than 95 or 100 times. Leave it. Here argon's composition is somewhat same, but see the nitrogen and carbon dioxide, here it's ulta in Earth. Nitrogen is more prominent in Earth's atmosphere. Water vapor here it's in Mars it's just 0.03%, while in Earth it's somewhat 1%. They are given atmospheric pressure, like it's 7.5 millibars, it's 1013 millibars at sea level. Can just compare the pressure, how much it's what you say less in Mars. Where is 7.5 and where is 1013? The deepest canyon, Grand Canyon in here, America, I believe. That's what. This is about something. This distance from the sun is 227 million kilometers. Here it's 149 million kilometers, 149.5. Like its equatorial radius, Mars is just 3,397, while our Earth is 6,378. Just compare the gravity right now. Gravity is, they are given Earth like that. Okay, 0.375 that of Earth means 0.3 into 9.8. If you just calculate 0. I'll just show you the calculation here. 0.3 into 9.8, 0.375 to be precise, into 9.8 I'll take. It's just 3.675 meter per second square. You can just assume what's the gravity there. And the largest volcano, Olympus Mons, it's the largest volcano in our whole solar system itself. Okay. And here length of the day they are given 24 hours, not 24 hours, it's 23 hours 56 minutes and 4 seconds. While in Mars it's 24 hours and 37 minutes, the length of the year, the polar caps, the surface temperature average, see how cold is Mars, the tilt of axis, like Earth is not revolving like this. If you just see, the tilt is somewhat like this. If you assume this is like North Pole to South Pole, if you take a straight line, the tilt is actually Earth is revolving like this. I hope you can see the visualization here. Like this angle made here is for Earth is it's 23.45 degrees, and they have given number of natural satellites. For Mars it is two, that is the Phobos and the Deimos. They are very small, and for us I mean the Earth, it's just one, that is Moon. They are named it as simple. Earth's moon is Moon, but for Mars they have given the special names. This is the crater, but these are all images of NASA's, because this brochure was released before the launching of the satellite itself. Then how can we expect like that? This I've covered in my PPT, so I'll rather explain. Sorry for the hang there. I don't know why it's lagging too much. So I think we should just go to the PPT here. I will just start the slideshow. Yes. So from beginning. Welcome. I hope you just it was just I just told you about the Mars itself. Now we'll just go deep about the PSLV C25 or the Mangalyaan mission. Like in the I think in the Amazonia launch I told the PSLV C25 it's the 27th mission. Why? Because if anyone is remembered, uh, I just told you that before the PSLV C1 launched, there were two developmental missions, two or three developmental missions. So they were counted. They are also counted as launches, but they what ISRO does is they name it as developmental launches. Like yeah, when I have GSLV Mark 3 M1, actually you just think there is only one launch of GSLV Mark 3, that is Chandrayaan 2, but actually there are three, because there were D1 and D2 launches of the GSLV Mark 3 version also. Got it. PSLV C25 Mangalyaan, a video on India's first video in the sense the presentation on India's first interplanetary mission. Yeah, we also reached the moon, but we do not count it as an interplanetary mission. It is an intercelestial body. Yeah, the main thing is Mangalyaan launched in the what is say 5th November 2013 and reached the Martian orbit at on 24th September 2014. This is just a dates. It's almost September and December 9-10 months journey, almost 10 to 11 months journey. 10 to 11 months it remained in the space. Just imagine. So we will go about the mission objectives. One of the main objectives of the Indian design mission to Mars is to develop the technologies required to design. See, this is the first time we went to Mars, so we were just experimenting if we can succeed with the other missions also, because Mars is not like easy as Moon. Like in Moon, there is a little delay in the signals just transmitting between the Earth's the ground station, that is the stations at the Earth and the Moon. But for Mars, it's somewhat like even NASA's Perseverance to if the spacecraft landed at somewhat 2:12 a.m. According to the mission control, actually it landed 12 minutes before there. So you can just the time lag is somewhat 12 minutes. Like if I send one data from here, not here to Mars, it takes 12 minutes to travel actually. And from one data to come from Mars to my station, it also takes 12 minutes. So you need somewhat 24 minutes for one go up down transition. Like you understood what are the difficulties, and almost all the landings just that take place are autonomous because there is a 12-minute lag. 12 minute means more like in the space science. It's not like railways and all. Even space science is one of the most complicated, and actually any mission if you do it, space science is the most complicated. Now we'll go about the technological objectives, and that is the nothing but we are just testing about our technologies required. Advan was cruise phase of 300 days. What do you mean by cruise phase? You just traveled in the space for 300 days. Understood. Just travel for 300 days. That cruise phase, what happened to its systems and all. In orbit insertion is nothing but a mass like somewhat captures it, right? Deep space communication, navigation, mission planning and management. How to deep space communication in the sense anything after the moon we regard it as deep space because there are thousands of kilometers difference. Incorporate autonomous features to handle contingency situations, somewhat emergency you might experience in space also. Scientific objectives. Explorations of Mars surface features, morphology, mineralogy of the Martian atmosphere because it's just an orbiter. We didn't send lander or a rover to Mars. Even like Mangalyaan to their just a week or two back, I saw in the news that Mangalyaan 2 will also be an orbiter mission because they just want to test the technologies again before landing. This is the total cost of the mission is approximately rupees 450 crore. Actually, it is one of the cheapest mission to Mars till date. Like 1 kilometer costed about for 7 rupees. It's even I mean the cheaper than the auto rickshaws rate in India. It's about if it is 7 rupees in the sense for 1 kilometer they charge you about 10 to 15 rupees now. So it's almost double. Just you can see the cost effectiveness of every ISRO's missions, right? The Maven's cost was somewhat 10 times more than it, 10 to 20 times more than it. Maven also it's like uh, Mars orbiter mission also, but it has some advanced technological things and all because it was not the first mission of NASA's. Okay, now we'll just go know about the spacecraft. This is the spacecraft actually the schematic diagram of the spacecraft. These are the three antennas: the medium gain antenna, the high gain antenna, and the low gain antenna. This is the propellant tank about 850 kgs. The total mass was I think it's described in the latest slide. I will just go. The solar arrays required for the what is a power generation of the satellite because you just can't take that much batteries to the space, right? And in space you have somewhat more sunlight, so you can just extract energy to the using solar energy, right? That's what. Mars orbiter mission. I hope you can see. Mars orbiter mission is India's first interplanetary mission to planet Mars. It's an elliptical orbit, like it is not a circular thing like the geostationary orbits. It's a elliptical orbits. Like it is somewhat 400 kilometers to 80,000 kilometers. Like I think I can draw a diagram just to this thing. This is my Mars. Like this is the orbit of the MOM. Like this kind of thing is somewhat, I mean the perigee you can't tell, somewhat extra terms because perigee is with respect to Earth. Perigee is respect to Earth. So this was somewhat 400 kilometers I believe. I mean the minimum was also somewhat less than 100 kilometer, but this was somewhat 80,000 kilometers. Like this is the orbit of the Mangalyaan. I'll change the pen back to the pointer. This is all about the propulsion and thing, but we just have the main things that are the payloads. What are payloads? The payloads are just going with the satellite, and they have some major, what you say, missions. Like we just not send a satellite. There is no use literally of just sending a satellite. When we just send a when we send a satellite to the other, even we when we send a satellite to outer space, or when we send the satellite to moon or Mars, we just want to extract data like the information about the Martian history, was life there on Mars, or even when you come to the Earth, the internet transmission, everything. Just sending a satellite is literally of no use. These are the five payloads: the Mars Scalar Camera, which is somewhat here, the Thermal Infrared Spectrometer, it's here, see. Methane sensor for Mars. Actually, this got somewhat malfunctioned during the cruise stage. The Mars exospheric neutral composition analyzer. That's sorry for this thing. Is the MENCA. The lymph and alpha photometer. We'll just discuss. Not briefly like that. Not like just a short points of what I got from the ISRO's website. This is a same table from the ISRO's website. The liftoff mass means the satellite mass was that time during the time of liftoff, which includes the full fuel, everything. That was only 1,337 kgs. This is a structure. Like we have, as I told in some videos, as I told in some videos, like there are separate types of bus types things for a satellite also. This is a type of one high 1K bus. A mechanism is solar panel drive mechanism, reflector and solar panel deployment, that thing. And this is propulsion they use is MMH and N2O4 with additional say, something Mars orbiter insertion. They used bipropellant system, and the propellant mass itself was 852 kg. Means if you just subtract 1337 minus 852, you'll just get 485. Means that 485 was the payload mass and every other thing mass. Okay. The thermal system, passive thermal control system, that is another thing there. The power system, they, as I told, they use the solar array. Like they are told that there was a 840 watt generation in the Martian orbit itself, and there was a battery like to store some, what is it, power. Is the altitude and control system. They have somewhat like known as stars sensor to just know the altitude, solar panels and sensor, and you have reaction wheels that they are separate things like reaction wheels, thrusters, the main thing, thrusters to just control the speed, to decrease or increase the speed, and 440 Newton liquid engine, liquid fuel it uses. As I told, the antennas and all, and the low gain antenna, mid gain antenna, high gain antenna. I just told in this just starting of the presentation. You can just go rewind back and see there. Launch date, as I told, November 5, 2013, from the Satish Dhawan Space Center, Sriharikota Center, and the launch vehicle was PSLV C25. This is what is it? This is the these are the payload fairings. Is the main satellite which is going to going to space. These are the payloads I just told. Is the methane sensor form was designed to measure. I'll just highlight things. Measure methane CH4 in the Martian atmosphere with parts per billion accuracy and map its sources. Methane concentration in the undergoes spatial and temporal variation. Its global data is collected during every orbit. As I told, there was some malfunctions in this thing. As per some sources, I think there was no confirmation there, and it's a Mars color camera. Every picture we got of Mars from the Mangalyaan was taken using this camera itself. It also took photos of the Phobos and Deimos. It also provides the context information for other science payloads and all. They are useful to monitor the dynamic events. Like there is some volcanic eruption, you can just monitor it. I think you can see. Otherwise, I'll just read it. This is the Lyman Alpha. Sorry for the bad quality there. I just got this pic, but no problem there. It's an absorption cell photometer. Like absorption cell photometer is a type of photometer. If you want, I will just make a short things here. It also measures the relative abundance of deuterium and hydrogen. Deuterium is nothing but in the its atomic number is 1 and its atomic number is 2. Mass is 2. That's what. It's used in heavy water. From Lyman alpha emission in the Martian atmosphere. This is also a type of emission in the Martian atmosphere. Typically, the exosphere and exobase. If you go to the Mars atmosphere, you have, like we have stratosphere, troposphere, ionosphere, everything. Even Mars, for Mars also we have designed the things. As I told, the DA by H ratio, generation of hydrogen, and deuterium coronal profiles. Somewhat more scientific. The Menka payload is this one. This is the symbol I think you can see there. Menka is a quadruple mass spectrometer. It's a mass spectrometer capabilizing, unlike it has more use in the spectroscopy. That thing. The heritage of, like I think you know about the moon impact probe in a Chandrayaan 1 mission. It actually got separated from the Chandrayaan 1 satellite and splashed on the south pole of the moon. Got it? That's the moon impact probe. This is thermal infrared imaging spectrometer. It's used for surface composition and mineralogy of Mars, mapping the surface composition. And they also calculate the temperature emissivity from this thermal emission experiment. Measure thermal expansion. They can be operated both in the Martian day and Martian night. This is a PSLV C25 launch time. Tool. Is the things of the stages at the science they have given everything there. Burn time in the sense how much time the solid I mean the fuel is burning. The diameter length of the stage 1 PSOM Excel stage 2 stage 3 stage 4. I'll try to make a video on the PSLV's rockets itself any next time. Is the ground segment. I think there is a photo. It's there. Isro telemetry track. This I think you all know. This is the place from where we get data from the deep space. They have big antennas. I think it's located at Pina, Bangalore. Will be providing support of the ground stations communications network between the ground stations and control center. Like you have so much centers of ISRO itself. After that, it just go to the space science data center. They analyze the data. That's too much complicated things there. This is the things like we also took help of NASA's space stations and from Australia's also, because while going to Mars you just needed stations all over the earth, because sometimes while uh, uh, inserting of Mars orbit we may get signal here, or for controlling some emergency we may get signal here, but this only we can't expect only from the Indian space center there. That's what they took help from all the space stations there. It's about the launch phase and all. Sriharikota. It launched from Sriharikota. Obviously, it will launch from Sriharikota itself. That ground stations at PSL, what a Port Blair, Brunei. Port Blair is here. Okay. Port Blair, Brunei here. I hope the mouse sound is not that much annoying. Okay. Two ships, as I told, there were two ships in the Pacific Ocean. They were just wanted to track the launch vehicle, because it was they wanted to insert the satellite in a specially designed orbit. So they required extra what you say antennas there. Yeah, I think you might have seen the Mission Mangal, that thing. Mission Mangal movie is the orbital phase. The spacecraft operation are controlled from spacecraft transmitter in Bangalore, Karnataka. But as I told, they took help from NASA or the Brazil and Sansa something, Brunei and Cuba. There are many stations they took help from. So you can just understand how much complicated the Mangalyaan launch was. Is the thing of the schematic diagram of the Earth. Departure was not at first; it was fifth, as I told, due to the rain things. But somewhat there will be less. Somewhat Earth may be here there, because this whole thing takes 365 days. So they had a launch period, like you have launch window. This special type of what is it trajectory is known as Hohmann's transfer orbit. You can just go to Google and search if you are more keen to know about the Hohmann's transfer, its equation, what are the special conditions. But the as many scientists say that Hohmann's transfer is now outdated, but also it's a yeah, what you say fuel efficient way. For direct transfer, you just need a more fuel to escape the Earth's gravitational field, right? What is the escape velocity Earth? It is 7.2 kilometers per second. 11.2 kilometers per second. Just you can just estimate. If you want to calculate escape velocity for any what you say uh, any celestial body, you can use this formula. Escape velocity is equal to root 2 gr. G is that what is a gravity acceleration due to gravity of that planet, and r is the radius. Derivation, it's going to gravitationally. This is what you say. Wait, I think I made a mistake here. It's not. This is not what you say. Wait a second. I think V is equal to root 2 gm by r. Just multiply r by r. Root 2 gm by r. You can just 1 second. You can also actually there was no confusion there. Where is the highlighter thing? V is equal to root 2 gm by r actually. Root 2 gm, this is the gravitational constant, but what I did was I multiplied inside the root itself I multiplied by r. So what is gm by r square is nothing but the acceleration due to gravity. You can use this formula also. You can use root 2 gm by r. There is no arm there. It's almost the same, not almost the same itself actually, but this is somewhat easier method if you just know the acceleration due to gravity. If you don't know anything, they have just given you the mass and the radius. You can use this formula, root 2 gm by r. Yeah, okay, let's come back here. They have given at the time of departure, that is the 5th December, it was Mars was here, but it's the base spacecraft trajectory, the yellow line, not I think you just follow the green line there. Just follow the green line there, you will get to know the spacecraft trajectory. See, the Mars orbit insertion took place on 24 September there. These are some geocentric phases. There are some. They are given also the escape velocity. What were the speed of the satellite? Everything. You just want to know. You can. This is a Pslv boost. The spacecraft injected to the elliptical parking orbit by the launcher. As I told, it was a special parking orbit by the launcher. That is the Pslv C25 with 6 main engine bays. Like I think there was some visualization in the Mission Mangal movie. Like she was. I mean, the scientist was showing like somewhat like this. What is say? Leave it. It just was like they increase the orbit. Like first, I think it's better. I hope you can see if this is first. It was like here. First orbit of Seleucid. After one maneuver, yeah, it was here. I mean, just see about this thing. After third year, fourth year, fifth year, sixth year, it was able to escape from the Earth's sphere of influence. That means at this point, it had a escape velocity to escape from the Earth. I hope I am right there. The sphere of Earth ends at 9,18,347 kilometers from the surface of the Earth, beyond which the perturbing force on the orbiter, that is the acting force on the orbiter, is mainly due to the Sun. After the 99,18,347 kilometers from the Earth, you are just out from the sphere of influence. Means Earth is not telling you to come back. Everything telling you to come back in the sense it's attracting you. See, I just told about the Hohmann's transfer, right? Or a minimum energy transfer orbit. That's what it requires the least amount of fuel. Heliocentric phase. As I told, I think it was there in the thing. I'll just explain the theory itself. The spacecraft leads Earth in a direction tangential to the Earth's orbit. Tangential, tangential in the sense, I have drawn a line there, passing. I think in the basic definition of tangent, it is a circle. It is if a line is passing just one point of the circle, this line is known as tangent. That's what. The flight path is roughly one half of an ellipse around the sun. Just think of the flight path. Eventually, it will intersect the orbit of Mars at the exact moment when Mars is there. Too. Like this is my Mars. This is my satellite. It's like they are going somewhat parallel, but at one point, it's like the satellite and as I told it, eventually it will intersect. Like the Mars is coming like this, Mars is coming like this. My satellite is also going at one point. That is on uh, for the Mangalyaan case, it was 24 September. The Mangalyaan is captured in the Mars orbit if the speed is correct. Like just take an example. Uh, if I am standing here and my friend is standing here, if he is going slowly, I can easily catch him, right? If he's going with the, my minimum like middle speed, I can still also catch him. He's still under my influence. But if he is going with more speed, I cannot catch him at all. Right. Just in the same case, when the satellite is approaching some sphere of influence, if it is more than the speed which is required, it will just pass. Yeah, it will just pass it. If it is correct, it will enter the orbit. If it is less, there might be a chance that it will crash land on the moon. So you just need to be so that much precise there. See, such a rearrangement, they are given the 44 degrees also. Earth, Mars, and Sun need to have formed an angle of approximately 44 degrees. Means you have some minutes and seconds also there. They occur periodically interview about 70 days means if you have like November 13, if you have missed the deadline, you have to wait till January 2016. So just you have to see the perfection here is the Martian phase. After it enters, ISRO plans to launch the Mars orbiter mission. This is from the website during which they what you say during before the launch itself. Arrives at the around 5,73,473 kilometers from the surface of the Mars. What was Earth's sphere of influence? As I told, it was 91,000, 9,18,347, but for Mars, it was 5,73,473. That's what. Where spacecraft reaches the closest approach to Mars, its periapsis here. I think I told you that. Then this is the just a photo there from the ISRO's website only. All these data I have derived from ISRO's website or either Wikipedia. Is like my satellite is entering here. No, here, sorry. The satellite is entering here like this. It was orientation. After that, it just reorient like 180-degree transition. Not 180-degree, almost the same transition. It just backfires so as to decrease the speed. Like if the speed is less going like this, like satellite was going like this and it was throwing gas here, obviously it will go in the forward direction. So there's a chance that it might increase the speed. What happens in the if you're coming like this, if your speed like this was 1,000 kilometers per hour, when you just go like this, what happens? The speed is like this. If you know the vectors, if direction was 1,000 velocity, I will tell because its velocity is a vector. It was 100. I will take 100 kilometers per hour, but here you are going direction of 60 kilometers per hour. What happens if you just do the vector subtraction? The resultant speed will be in this direction because obviously 100 is greater than 60 and the magnitude will be 40 kilometers per hour. You are given 100 speed from here. You are pushing 600 here. What happens? It will just go with 40 kilometer per hour. I hope you understood that. And about the engine burning, they are given the communication blackout. I think you have just seen the if you have seen the Mission Mangal movie, the satellite was off for about 24 minutes. They were just getting tensed. Even in the case of Chandrayaan 2 also the 15 minutes were the deciding factors. Even in the case of Perseverance also the 7 minutes was the most what is it deciding factors. Rotating the spacecraft and everything. It's about the things everything. There was actually a incomplete burn here at 10 but our great ISRO scientists just managed to plan another burn in just a short period of time to just increase the orbit. Orbit reaching maneuver, there were total one, 2, 3, 4, 5, 6. There was an incomplete one, but I will just count it as a complete one itself. And there was a trans-Mars injection. Means it will leave the Earth sphere of influence, just going. See, this is the cruise stage, December 13 to December 2013 to September 2014. It is all, you can just call it as a cruise stage. There were trajectory correction, like if somewhat due to trajectory was this and satellite was going like this, you have to correct it, right? There were some trajectory corrections also. They had planned for second trajectory correction, it was not required. They scheduled it for some other day, like that, everything. And the heliocentric phase, the Mars orbit insertion was the successful mission. Like you have in history, India is actually the fourth country to enter Mars, but it's the first country to enter Mars in its first attempt itself. Even Dubai in the sense United Arab Emirates just I mean 1 or 2 weeks back, 2 or 3 weeks back, but we did the same thing 6 years ago. Just be proud of being an Indian. Just be proud of ISRO scientist. And these are some of the animations, like you can just see the spacecraft on the Earth's what is say earthbound phase. See here it is the biggest orbit. After that, see after some time it will leave. Wait for 30th December, see it's orbiting. They are given the orbital velocity also. See now it will leave. It just left here, right? So it's increasing its orbit, increasing slowly, slowly, slowly. Then a bigger one, another one. It will do. See the thing. Now it will leave in 30th December. Now it's 24, 25, 26, 27, 28, 29, 38. Just left here. There is another visualization also there. This is what you say. Spacecraft trajectory. See, it left Earth here. It is entering Mars 6 June, August, September, October, no, September. I just now Mangalyaan is in Mars orbit right now. This is a visualization. This is from borrowed from Wikipedia. You can just check there. It's the Mars orbit insertion. See, Mangalyaan entered Mars orbit and it's just doing the orbits like this. There's some orientation. And these are some of the beautiful pics of the Mars captured by our Mangalyaan. This is not that much clear, but if you go to the ISRO's website, it's clear like anything. It's perfect for a if you are a space geek. It's perfect for a wallpaper or a desktop wallpaper. Everything. This is the ISRO's. This was there in the first. What is in the brochure? It's also a testing thing. These are the satellites. This is integrated with the fourth stage of the PSLV. This was the testing, and on moment, if you have just a 2000 note, take it out. If you have take it out, then just turn it back. You can see the Mangalyaan. Just it's a proud moment for India, right? And it is actually the best thing the government did by printing the Mangalyaan in the 2000 notes. It's the Power Yori. I know I can't just play the song. I know they'll become copyright, but it's a real party here going on. It's a pride moment for Indians on that day. You will just get goosebumps if you just watch the even in the Mission Mangal movie. Then he says copy that like every Indian is sure to get a goosebump there. These are the celebrations there. These are a great team. I mean the greatest team who directed the Mangalyaan mission, Radhakrishnan sir as the ISRO chairman, Mailaswamy Annadurai sir as the program director, Ramakrishnan sir and P. Krishnan sir. There are some major women scientists also, like Ritu Kardiyal ma'am is also looking after the Chandrayaan 2 mission also. Anil Harinath ma'am, Kiran Kumar sir is from Karnataka. He was also the former chairman of the ISRO. And there are some things. So I think you just enjoyed what I said in this video. Please like, share and subscribe my channel. If you want some more videos, if the video is too lengthy, I'll try to make one short. But I think you just gained good knowledge from the video. If you gained a good knowledge, please like, share and subscribe my channel. If you want to share this knowledge, please share to as much as space geeks around you. If you think there was some mistakes or a correction, please be free to tell in the comment box. Thank you very much. Jai Hind, Vande Mataram, stay safe. Thank you. I'll be ending the show here. Yeah, no discard. Thank you very much, guys. Stop.